In this video, we will discuss adding surfaces, regions, solids, and 3D faces. If you'd like to follow on with this video, please open the file adding surfaces-regions, solids, and 3D faces.dwg located in the working files folder as discussed in the working with this dataset video. In this video, we will actually finish developing the rest of our house using surfaces such as regions, solids, and 3D faces. Let's first examine the settings that we should have turned on. First, verify that dynamic input is turned on. Polar tracking is turned on. You have endpoint, midpoint, center, node snap, intersection, and extension turned on. And you have selection cycling and 3D O snap on as well. So the first thing we're going to discuss is how to actually create some thickness to our walls. We have started out with a 2D wireframe of our actual building. Let's examine one tool to create a face, and then we'll examine another way to actually do this much more efficiently. Let's first examine the solid command. This command does not exist in the ribbon. You simply type in SO for solid. Notice that we have two viewports open. This viewport has a wireframe displayed, and we have the UCS set to this wall right here. This viewport is set to a conceptual, so we will be able to see the shading that may occur as we create different object types. So let's first start the solid command by snapping to the endpoint of this line right there. Then we'll snap to the endpoint of this line right here. Now you might think you want to create a square, but that is incorrect. You actually have to create the triangle part first and then go to the other corner. To do so, we can very quickly use O tracking to acquire this point here, go straight up using O tracking, and type in 6 feet, press enter, and then do the same thing on this side, acquire, move up, 6 feet, and there is our solid object. We could keep going, creating these solid object types. As you can see here, it's shaded in this view, so it is actually a shaded type object, but this is not the most efficient way to thicken or show walls. To very quickly do this, let's first delete this. There's an option with standard AutoCAD objects that allows you to give something called a thickness. You can think of this as a height of some sort. Let's first change our UCS back to the WCS. We'll select one line, right-click, select similar to select all of our lines in our drawing. Now, let's unselect by holding the Shift key down and deselecting these four objects here, as these four objects will have windows and we will need to define them with a different type of object. So now let's navigate to the Properties palette and let's simply change the thickness, and watch how simple that is to actually give your line work some really quick height. It even shades it for you in a shaded view. So that's just a really nice and quick and much faster way of getting some thickness than using the solid command. Let's go ahead and finish these walls. The command we're going to use is the 3D face command. And that's because we want to actually segregate this part of the wall here, this part of the wall there, and so on. So this command too does not exist in the ribbon. So type in 3F and press enter. With this command, you can go in a rectangular type shape. So we'll snap there first. We'll snap here. Using node snap, we'll O track and again, acquire that point, don't click. Left click, and then simply go to the intersection and press enter. And there is our 3D face. Again, as you can see, it's showing up in the shaded view. Press enter to repeat the command. And now complete the window by simply acquiring and tracking the correct points. Notice how you only have to do 3, as this is all that's required to complete the 3D face. Again, just using O tracking to acquire the different points and intersections. And we'll finish here. Don't forget to do a shift middle click to rotate your view while you're in the middle of the command. Note sometimes ortholock does kick in and you will have to put polar tracking back on. Now let's go ahead and simply copy this wall here. So we'll just use the regular copy command to copy this 3D face onto the back side of the other wall. I'll just acquire this point here using O tracking and grab it like so. We'll fix that other intersection in a minute. Copy again using O tracking, and there's our completed copy. Now we do have a bit of a problem as we have some overlap into this wall here. To fix this, you could use the stretch command. However, using grips, there's something called hot grips that you can apply to grips to stretch them both at the same time. The way you make a grip a hot grip is to hold the Shift key down and select the grip again. Notice how it made them red, and now when I modify one, it actually will modify all the grips. Press Escape to clear your selection set, and perform the same edit using this hot grip functionality on this wall here. Now we can finalize this by copying the following walls here as well. So we'll just copy these two walls from this endpoint here to that endpoint there. Now we want to actually create a windowsill, let's say, because as you can see here, there is some sort of gap in between. If we look at the shaded view, there's a gap of some sort, right? So to do so, let's think out of the box. You could try and create a 3D solid of some sort, or you could maybe do another 3D face. You actually don't need to. Watch how simple this is. First off, let's measure the distance of the thickness of this wall. This is 5.5 inches. So what we can do is we can actually draw a line and make sure that the line is starting at this UCS here, and we'll give it a thickness so it'll just fill in that gap that's between the walls and the window. So let's type in TH for thickness and type in 5.5 and then press enter. Now let's move our UCS icon to this window's location like so. Now we have the X and Y going this way, but that's actually incorrect. Remember, the thickness is the Z height that's going to actually be applied. So we need to move this down to the direction below. If we move it straight up, the Z will come towards us and not into the building. So just pick your Y axis, move it straight down, and now let's just draw a regular polyline. So we'll type PL for polyline, and watch the other view here as we draft this windowsill. It'll automatically close the actual gap. Pretty cool stuff. This wall has some windows. There are some pre-created points that you're going to use to create the window part. The first thing we're going to do is simply draw a polyline that outlines the wall. So let's go ahead and do that. First, let's change our UCS back to the WCS. We'll change our thickness back to 0 as we don't want to draw a polyline that has a thickness. Now, before we start the polyline command, we have to rotate the UCS to go straight up because as we draft here, it's going to draw onto the actual ground. So pick the UCS icon. Using the Y-axis, we'll move it straight up like so. You don't have to move it onto this point here because as soon as we snap, it's going to go on here and then parallel project the polyline. So we'll start the polyline command, snap to the endpoint here, endpoint there. And the great thing about the thickness is that as you can see, you can actually snap to the thickness or height of that wall right there. That's a pretty cool functionality. Again, don't forget to do a shift middle click if you need to rotate your view to get to the angle of rotation you need to be able to see your data. We'll go over here. We'll go straight down. And then we'll go over here. And then now what I want to do is I want to go straight up. So we'll go ahead and lock our Z height and we'll type in 7.5 feet. Press enter. Now we're at that height. Acquire, but don't click that point there. And then simply using O tracking, you can grab the projected intersection of that point. We'll type C for close, and now here is our wall. Let's draw a rectangle to simply draw a rectangle from there to there. Now we can go ahead and copy this to represent the other window openings. So now that those windows are done, how can we get them to look shaded in this view? What you can do is convert them to regions. A region is simply a 2D surface. So first, the region command is located in the Home tab, Draw panel, and here's the region command. You can also type in REG. All you have to do is simply select the objects within the file that you want to turn into a region and press enter. So we'll select all the windows and the wall, and notice how they're all now regions. The reason we created regions was to not only get the shading, but to be able to use the Boolean operations to subtract out the holes, which would be, of course, the windows. So let's go ahead and go to the solid editing panel and navigate to the subtract command. And the way the subtract command works is you select the object first that you want to subtract from. So we'll pick the main wall object there and then press enter. Then you will select the window objects. And there is our wall. Pretty cool stuff. Let's go ahead and turn on our roof layer and make it the current layer. And now let's go ahead and freeze the wall and the window layers, as well as the no plot points. We want to create some sort of solid area where holes exist. So for this, what we can do is simply create regions of these areas. So let's examine what we have. First off, we have a polyline here, and we have a line here. So to make a solid out of this area, it's pretty simple. Just navigate to the Draw panel, Region tool, and you can actually collectively choose objects that aren't actually connected. Press enter, As you can see, you now have a region surface that you can apply a material to if you wanted to. We'll do the same thing for this side, for center, and now we have that. Let's go ahead and thaw all our layers and notice the completed design. If you'd like to add additional solids to the roof, you can do so, but make sure you set the UCS to the projected angle of those different planes on the roof. Now, if we go to our layout, here is our completed design of our 2D wireframe building. Again, if this is good enough to get your design intent across, then this is good enough, and there's no reason for you to actually create 3D solids whatsoever. If you need to annotate these objects, for instance, show dimensioning and text, you can do so either in paper space, which we're in right now, and we can draw dimensioning right here, or you could actually do it in model space as well. Don't forget, if you want to actually dimension an elevation of a view, all you have to do is simply move the UCS to the correct location and orientation. So right now, if I were to actually dimension, you will see as I snap to this point here and this point here, it automatically shows you the dimension at the correct actual view's rotation, because all it does is it simply gets placed on the UCS's plane. Really cool stuff.